Welcome to this video on partial fractions. So this video is covering the content required for Edexcel International A-Level Pure 4. It's one of three videos. So the first one is partial fractions, the second is repeated factors in partial fractions, and then we'll also look at improper fractions in the third video. Just before we get started, if you are not comfortable with these types of questions, then you may need to go back and just check you can do these. I've put the answers for these in a link below the video. So just if you want to try them just before the video starts, go ahead. Right, so let's get started. So a single fraction. Now when we talk about a single fraction here, we mean something along the lines of a rational expression with two distinct. Now distinct here means different or unique. So no repeated roots just yet. And this can be split into two separate fractions with linear denominators. So these are the factors that we're talking about. So if we have a look at this fraction, this would be split as a over the first linear factor, which is x plus 1, plus b over x minus 2. Ooh, like so. All right, so let's do some examples. All right. So this is example 1. I'm going to show you two different methods. So I'm going to show you firstly substitution. So we'll do this one in red. So I'm just going to start by rewriting my fraction so I can equate it underneath to the new form. So this should be a over x plus 1 plus b over x minus 3. Now what I'm going to do is I'm going to multiply everything by x plus 1 and x minus 3. So the next line of working should say that 3x minus 2 equals, now if I multiply it by x plus 1, x minus 3, the x plus 1 in the denominator should be cancelled out. So I get x minus 3 plus b times x plus 1. Okay, now the goal of substitution is to make sure I can eliminate the constants by substituting appropriate values in. So let's say I want to eliminate the constant a, then I want it to multiply by something that is 0. So for this one, I would say let x equal 3. Now when I put 3 in, what I should get is I should get 9 minus 2, so that's the 3x on that side, equals a times 0 plus b times 4. All right. Sorry, should have laid my working out nicely. So I get 7 is 4b, and therefore b is 7 over 4. Just put a box around that. Okay. Now, this time I want to eliminate the b constant. So I would choose this such that it's multiplying so that x plus 1 becomes 0. So that will happen when x is equal to negative 1. So then on the left hand side, what I should get is I should get minus 3 minus 2 equals a multiplied by negative 4 plus b times 0. So from that I get minus 5 equals minus 4a, and therefore a equals 5 over 4. Okay, put a box around that as well. So now our final form would become a, so I'm going to write a as 5 in the numerator, and I'm going to combine the 4 in the denominator like so. So I get 4 times x plus 1 plus, and it's 7 over 4 again, x minus 3. Okay. So this is our final answer. All right. Now, moving on. So let's do the same example, but using a slightly different method. So this time we're going to use equating coefficients. Okay. So it starts off exactly the same. So I get 3x minus 2 over x plus 1 multiplied by x minus 3, and this equals exactly the same. So it's a over x plus 1 plus b over x minus 3. And then we go through and multiply again, so we should be familiar with that from the last one. So we get 3x minus 2 equals a times x minus 3 plus b times x plus 1. Now, instead of substituting here, what I'm going to do is leave the left hand side as it is. So I get 3x minus 2. And I'm going to expand the right hand side. So I'll get ax minus 3a plus bx plus b. Now if I collect my terms, so in front of the x I'll have a plus b as the coefficient, and then I'll get plus b minus 3a. Okay. Now what we can do is we compare the coefficient of x here with this one. So this will become equation 1. So I'll get 3 equals a plus b. And for equation 2, I will get minus 2 equals b minus 3a. Now from here, you can do it a couple of different ways. I'm going to do 1 minus 2. So I get 3 minus 2, which is 5. I get a minus 3a, which is 4a. And then I get b minus b, which cancels. So I get 5 equals 4a, and therefore I get a equals 5 over 4 again. Alright. Then I can just put this in here and I'll get a plus b. So I get 3 minus 5 over 4 is b. And therefore b would be 7 over 4. Okay. So two different methods. There is nothing to say you can't combine them in any way. So if, for example, we'd have put x equals 3 into this, we'd have eliminated a, and then you could compare the coefficients again after that. So once you had a value for a, you could then compare coefficients. Okay? Right. We'll move on to the next example now. So in this one, it looks slightly different. We have 6x squared plus 11x minus 5, and this time we have 3 factors on the bottom. Now, they're all distinct, so we can still follow the same format that we used in the last example. I'm just going to start by rewriting it. So I get 6x squared plus 11x minus 5 over, and I get x minus 1 over x plus 1, x plus 2. And this will just be a over x minus 1 plus b over x plus 1 plus c over x plus 2. Okay, so again, we're going to multiply up. So on the left hand side, I'll still have my 6x squared plus 11x minus 5. And a quick way of doing this is whatever's here, you just got to remember it's the other two that get left. So I'll get a x plus 1 bracket x plus 2 plus b, and I'll have x minus 1 and x plus 2. And I'm just going to write below here because I'm limited on the space. So I get x minus 1 and x plus 1. So x minus 1, x plus 1. Okay, now I'm going to use substitution in this one just because it can eliminate things quite quickly. So I'm going to start by eliminating a and c. So for that one, what I want to get rid of is the one factor that they don't share. So this one, if I eliminate in both a and c, if I let x equal minus 1, by the way, there's no order you have to do this in, so just as long as you're comfortable, you can do it in any order. So let x equal minus 1. So when I put that in here, I'll get 6 minus 11 minus 5. And then what will happen is I'll get a times 0. So I can just put times 0 plus b. Now b will not cancel. Okay, so I'll be left with b times minus 2 times 1 plus c. Now because this factor cancels, it's just c times 0. So what I'm left with here is I've got minus 16 on this bit and 6. I've got minus 10 equals negative 2b, and therefore b is 5. Okay, so that's our first one. Now it doesn't matter any order I said, so you can do them however you like. So I'm going to say this time I'm going to get rid of let's say b and c, because if I put x equals to 1, this will cancel and this will cancel. They'll just be eliminated to 0. So on the left hand side, I'll get 6 add 11 minus 5 equals, now a is the one that won't be cancelled this time. So I'll get a times 2 times 3. 2 and 3. And then I'll get b times 0 plus c times 0. Okay, so altogether this becomes 6 add 11 is 17 minus 5, so I get 12. And I'm left with 6a, so a is 2. Alright. Now, again, we're going to use substitution for the final one. If you really wanted to, you could go through and expand them and then equate coefficients, because now you have a and b, and you'd only have one equation. So it wouldn't be like a set of simultaneous equations. But the last value, so we need to find what c is, so we want to get rid of the x plus 2 that's in the other two, so we're going to let x equal minus 2. So 6x squared becomes 6 times 4, so I get 24, minus 22, minus 5 equals, now a will be multiplied by 0 and effectively cancel, b will be multiplied by 0 and also cancel, and then c, I'll get c times negative 3, and minus 2 add 1 is just 1. So what I get here is I get 24 minus 27, which is minus 3, equals negative 3c as well. Therefore, c is just... Oh, sorry. This should be negative 1. So c, that's plus c, so c is negative 1. My mistake. Okay, so this will then become 2 over x minus 1 plus 5 over x plus 1 minus 1 over x plus 2. And that's the final form for this one. Okay, right, let's have a look at example 3. Now, this one has one linear factor and it has a quadratic. So let's start, I'll just write the numerator out again. Over x plus 1. And remember, partial fractions will only work if we have distinct linear factors. So we know, if this is being asked as a question, that this must factorize. Okay? And it's safe to assume we're not going to have to use the quadratic formula. So I need to find two numbers that multiply to make negative 6 and add to make 2. So that's going to be minus 2 and plus 3. So now we've got that, we can write out our form. So I'll get x plus 1 plus b over x minus 2 plus c over x plus 3. And we should be getting familiar with this stage now. So my next line of working will say 3x squared plus 21x plus 6 equals a, and remember, it's just the other two that are not in the denominator. So I get x minus 2, x plus 3, plus b times x plus 1 times x plus 3, and I'll put c below again. So I get c times x plus, x plus 1, x minus 2. Okay? And let's just go through. I'm not going to do these in any particular order. I'm going to start by getting rid of this. So I know that if I let x equals 2, okay, then my left hand side, so I get 3 times 4, so I get 12, add 21 times 2, which is 42, add 6, equals, I know that this a will cancel now, so a times 0, plus my b will not cancel, so I'll get 2 add 1, which is 3, and then I'll get 2 add 3, which is 5, plus c, and since that one is 0, the whole product is 0. So if I add these up, I get 60 equals 15b. So b must be equal to 4. Alright, let's go again. So I'm going to let x equal, now let's have a look. So this one cancelled, so let's cancel this one now. So minus 3. Alright, so when I put this in, I'm going to get 3 times minus 3 squared, so I'm going to get 9 minus 63 plus 6. Oh, that's not 9, is it? Silly mistake. Sorry. So, what I'm going to get here, I'm going to get 3 times 9, not 3 times 3. So I get 27 minus 21 times negative 3, which is minus 63, plus 6 equals, Now my a will multiply by a 0. My b will also multiply by a 0. And c, I now get minus 3 add 1, which is minus 2. Plus c times minus 2. And I get minus 3 minus 2, which is minus 5. So on the left-hand side, what I've got is I've got 27, add 6, which is 33. So I get negative 30 equals 10c. So therefore c is negative 3. Final one now. So I've eliminated both from this, so now it's going to be x equals negative 1. So when I put negative 1 in, I get 3 times 1 squared, which is 3. Let's see if I can do the multiplication this time. Plus 21 times negative 1, so that's 21 minus, and then plus 6. Okay. So now b and c will cancel, and what I'll be left with is I'm going to have a, and minus 1 minus 2 becomes minus 3, and minus 1 add 3 becomes 2, plus b times 0 plus c times 0. So on the left hand side here I get negative 12 now equals minus 6a, and therefore a is 2. Okay, and I should just have enough room at the bottom here, so I get 2 over x plus 1 plus 4 over x minus 2. And when we've got a negative, it looks just much neater if I do the minus the entire fraction, as opposed to writing it as plus minus 3. Okay, and there we go. That's example 3. Last one, called the exam style question. So it's just a very different form, but since we know it is partial fractions, we can notice that there's no linear factors here, okay? But we notice there's a common factor of x, so let's start by just taking the x out. So I'll get 4 minus x squared. Okay, so let's rewrite our numerator. Now, 4 minus x squared, hopefully you notice that this 4 is also a square. So this essentially becomes x, and this is now the difference of 2 squares. So I get 2 minus x, 2 plus x. Okay, now the x doesn't have to be at the front as long as they are linear. So I get a over x plus b over 2 minus x plus c over 2 plus x. And from now on, it's a pretty standard partial fractions question. So we're going to get 4 plus x squared equals a. And remember, we just get left with everything that's left. Now, for this stage, what you could actually do is you can just multiply up by 4 minus x squared. Okay? But I'm going to stick with the method that we've used throughout the entire video. So 2 like so, and I'll get bx 2 plus x, and I'll get c underneath here with cx 2 plus x. Okay, right, let's start with the easiest one, arguably. Let's get x equals 0. So the left hand side, what I'll get is I'll get 4 equals, and I'll get a times 2 minus 0, so I just get a times 2 times 2, plus b times 0 plus c times 0. Alright, so I get 4 equals 4a, and therefore a is 1. Nice. Right, let's keep going. So let x equal 2. So if I let x equal 2 now, I'll get 4 add 2 squared, so I get 8 equals a times 2 minus 2, so a times 0, plus b times 2 times 2 add 2, which is 4, add c, oh, made a silly mistake here again. This one should be minus, oops, okay, c times 0. You can tell I did that wrong because I knew that I should have 2 being eliminated. So now 8 equals 8b, and b is therefore also 1. Okay, last one, let x equal -2. So on the left hand side I'm going to get 4 plus x squared, so I'm going to get 8 again, equals, and I get a, this time the second bracket will cancel, so I get a times 0 plus b times 0 plus c times -2 times plus 4. So I get 8 equals minus 8c. So therefore c is -1. So I get 1 over x plus 1 over 2 minus x minus 1 over 2 plus x. And we're done. Okay, if you found this video useful, please like and subscribe.